Now let me get back to my original diagram, which is showing the rational. Now the earlier I showed you in a profile view. Now I am showing in a bird's eye view as taken from the zenith. This is a photograph which is clicked from the zenith, which shows your east-west points, as I said, north-south points of the observer, because observer is considered to be here. We are interchanging between equinoctial, equator, observer on the Earth's surface, observer at the zenith. So that is all to make it easier for you to calculate. That is all for ease of calculation. That is called the geographic position. I'll come back to that later. So now we come to prime vertical. We got vertical circle. Now let us see prime vertical. Prime vertical is the vertical circle passing through the east and west points of the observer. I'll come to it later. Just get the definition of principal vertical. So for example, it is in this case WZE is a prime vertical, because Z may anyway vertical circle is passing. So I can put that here in bracket. WZE or EZW, whatever you want. Principal vertical is the vertical circle passing through the north and south points of the observer. So in this case, it would be north Z south. That's the principal vertical. Now we come to the now when I say latitude is, what is the definition of latitude? Anybody can tell me?
Yes, sir.
बोलो latitude का definition क्या है?
Sir, it is the arc of the meridian or the angle contained between the equator and the parallel of latitude, so passing through that point.
Perfect. So arc of the meridian. So this is the meridian of the observer, because observer is here and this is a great circle. Vertical circle is a great circle. This is the meridian joining north and south point. So this is the meridian of the observer. So we can say that if I say latitude is 30° north, so observer will be equator will this becomes the equator, where it is Q. Is north. It means observer is north of the equator, correct?
Yes, sir.
It means equator is south of the observer.
Yes, sir.
It means if Q is equator, it will be south of Z.
Okay, sir. Okay.
By how
got
much?
it.
30°. If Z is 90, ZQ will be 30. So approximately 1/3 like you can draw. So we can say that,
Yes, sir.
yeah, if latitude of observer is 30° north, then equator will be 30 degrees south of observer, which is Z. Then equator will be equal to WQE. Got it? How we got WQE? Because this you'll be using extensively in your district. Now, yeah, ho gaya to both. Then we'll come on to the next. Always remember that if the latitude was south, then equator will be north of the observer. Then the equator would be like this, as south, because then Q would be north of Z. Look at the diagram. Here we said Q is south because the latitude was north. Here the latitude is south, the observer is south of the equator. So WQ will be on top. Okay, na? This is in case of south. We'll come to it later, don't worry. Okay. Now, what is the definition of declination? Who can tell me?
Sir, it is the arc of meridian on the celestial sphere, or the angle between the between the equinoctial and the declination of the circle.
And the declination circle passing through the body.
Passing
So
through
arc
the
of the
body.
meridian again. So this is the meridian. So if I say that declination is 10 degree south, so where will the body be? 10 degrees south of what?
It will be 10 degrees south of equator.
Correct. 10 degree south of Q. तो अगर तुम्हारा Q is 60 मिला, तो 10 degree इधर आएगा, and then you can draw the declination circle. Normally you draw as a dash circle, not a continuous circle, otherwise it will confuse with the other things. This is the declination circle. Declination circle, because all bodies would move around the pole with a radius equal to the polar distance. I'll come to that. First of all, let me draw the pole. Now they've got the pole. So now definitely pole is 90 degree from equator. So अगर Q यहाँ पे है, तो pole इधर होगा. Right or wrong? Correct. Now let me remove the declination now. Declination just for your understanding I did. I'll come back to the declination later. Let me do the pole first. ये हो गया pole. Now in this we have, let me remove this. Okay. In this we have, if you see this, PQ, what is PQ? By definition, is equal to 90 degree. Yes?
Yes, sir.
What is Zn? Okay, but PQ is also equal to PZ plus QZ. Right or wrong?
Yes.
Correct. Now, Zn is equal to what is again 90 degree, because by definition, from the zenith to the rational horizon, go 90 degree. But Zn is equal to Pz plus Pn. Correct? Therefore, we can say Pz plus Qz is equal to Pz plus Pn. So Pz will cancel. And what you get is Qz is equal to Pn. What we have here then becomes, let me just delete this. Qz is equal to latitude of observer. What is Pn? Pn, it is the arc of the vertical circle between the pole and the rational horizon, no? So can we say Pn is the altitude of the pole?
Yes, sir.
Altitude of the pole, because that is the vertical circle ultimately, no? Nz is the vertical circle. Therefore, we can say that latitude of observer is equal to the altitude of the elevated pole. We always say, because only one pole you can show, but it is elevated pole. That means the pole that is there in your, there's one more pole that will be opposite to your, it will be somewhere, say, that would be somewhere here, but that is of no difference here. That is the south pole. If this is the North Pole, in the northern hemisphere we can only see the North Pole. Then this would be the South Pole. That is the depressed pole. But we don't have nothing to do with depressed pole. We want to do everything with the elevated pole. This is called elevated pole. Elevated pole. And this is called the depressed pole. So latitude observer is equal to the altitude of the elevated pole. This is the base on which we do Polaris calculation, but that is later. Here we need it because we need it for the PZX triangle. यहाँ तक किसी को कोई दिक्कत है तो बोल दो. Correct. In the northern hemisphere, the North Pole. In the southern hemisphere, the South Pole. That is the depressed pole. In the southern hemisphere, the South Pole will be the elevated pole. Now, can I remove this calculation which I have written over here? Anybody?
So just 1 minute.
Yeah, because then I can draw the southern hemisphere and then I will show you how the South Pole becomes the elevated pole and the North Pole becomes the depressed pole. This is a typical question you will get, a 15-mark question. Prove that latitude observer is equal to the altitude of the elevated pole. So you have to draw the diagram and you have to write this and say latitude observer equal to that.
Sir, how Pn is the altitude of the pole?
That we have proved. No, it is equal to QZ. No, Pn is altitude. No, that is the vertical circle between the body and the rational horizon. By definition, altitude of any body is the arc of the vertical circle between that body and the rational horizon. Here the N is the rational horizon. N, E, S, W is the rational horizon. And this is the body. If the pole is the Polaris or the pole star, then that is the Pn becomes the altitude. Now let me show you. Same thing, how it will look when you're doing the northern hemisphere, the southern hemisphere. As usual, I draw the principal vertical. I draw the prime vertical. Now I say the latitude is 30 degree south. It means Q equator will be 30 degree north of the observer. If this is Z and this is north, east, west, south. So in this case, my equator will be here. This is the equator. This will be Q. So now what happens to the elevated pole? That is 90 degree from Q. So the south pole in this case becomes this is the south pole. And the north pole is somewhere 180 degree from there. That is meaningless. That becomes the depressed pole over here. That doesn't happen in our calculation. So that's why we say always elevated pole. So this is the southern hemisphere. In this case, PS, altitude of the elevated pole, is equal to the latitude of the observer. So that's by observing the altitude of the pole star and applying certain corrections, we can get the latitude of the observer. So when you're in the northern hemisphere, the North Pole is the elevated pole. When you're in the southern hemisphere, the South Pole is the elevated pole.
The PS is latitude of observer.
Correct. Same method what we did. That in this case, we can say that PQ is equal to PZ plus ZQ or QZ, whatever you want, QZ. And we can also say ZS is equal to PZ plus PS. Therefore, we can say PZ plus QZ is equal to PZ plus PS. So PZ cancel. Same method you can do for the south. PZ cancel. Therefore, QZ is equal to PS or we can say latitude is equal to altitude of elevated pole. That's all. I have done it for you for the southern hemisphere and for the northern hemisphere. Any doubt, anybody in this? Can I remove everything now on the board, clear the board?
No, sir.
Done, everybody?
Done, sir.
Okay, let me clear the drawing now. Let me get this one and just clear this one, this part. Trying to draw again all over. Okay. Now, if I say declination, by definition, declination is the arc of the meridian between the meridian of the body between the body and the equator. So, if I say declination, say latitude I gave as 10 degree, 30 degree north. Declination I gave as 15 degree north. So then the body will be 15 degree north. So body will be in between this because 15 ये QZ अगर 30 है और ये 15 है तो ऐसा होगा. And we know that all celestial bodies, okay, I'll give one more. The earth rotates on its axis once a day. That we already know. But for purposes of navigation, we consider the earth to be stationary. Thus, all celestial bodies appear to revolve around the pole with a radius equal to the polar distance, where polar distance is equals to 90 degree minus declination, where polar distance equal to 90 minus declination if lat and dec same name and polar distance is equal to 90 plus declination. I'll show you on the board how it is. If lat and dec different. Polar distance is referred in the PZX triangle as Px. So actually what happens, okay, we finish writing, then I will tell you. So now what happens to the celestial body? Let us take our declination, our star at 15 degree north as usual. So it is going to revolve around the pole somewhere like this. It will go. This will be. Let me just replicate it with the my just to get a nice diagram. I'll just draw the over here. Then I will remove that circle only. No, I'll do a dash line. But as you know that I'm doing dash line. Only for your understanding that how the this particular star which was revolving around the pole, how it is visible to us. Now normally what happens, it is revolving on the pole with if this is x with a radius equal to the polar distance, and it is here, it is the horizon, it is coming above the horizon, it is rising, then it will come on the meridian and it will set. But what we see, we won't see the full circle, we are only seeing the over here. This is what we are seeing. So this is how you have to draw. Always remember when you're drawing, this end would be a little bit elevated more than the because it is going around the pole, no? So that means it is rising over here. It is rising over here, coming on the meridian over here, and setting over here. So along his journey from rising to setting is what we call as the PZX triangle we can form.